Thank you. Berko, you're making me nervous with all the compliments. Right. So it's about, it's not about making fast something. It's about making it work fast, like a speed and performance way, because, yeah. So I worked at Paylogic as a Python developer 10 years ago. That's how I'm here now. And for the last, is it working? Yeah. For the last 7 years, I'm a CTO. I'm my own Berko. Well, feels nice. At a pretty big marketplace in Ukraine, we're second by market and first fashion-oriented and whatever. We're doing around 10,000 packet orders per day, which is like, it's quite a bit. And 2000 RPS, it's a normal, it's like not a peak sale load, it's just a regular day. Not a night, just, at night it's like, 300 maybe. Anyway, we're going to, you're going to listen to like few stories about our pain, how we tried, how our marketing did a sale or not, just a regular day, and we just failed it somehow, and then how we fixed that shit. Let's start with an ancient history. That is the oldest story I have. And at that point in time, we moved to a new platform in Clojure and Clojure 3, single-page application in React, and it's fancy and new, and it's in production since February, so it's for half a year, and we're going to have a first big sale on that platform in August, and we have a really weird issue. Like, if you have 300 people on the site, 300 RPS, everything's working fine, load average is like 0.1 or something, 1.0 maybe, I don't know. And then like 400 RPS means you have an LA of 80 or 120 or something. You can't even connect to the JVM or nothing is working. And everything was new for me, and I was a little bit nervous. My son was 2 weeks old at the time. I was sleep deprived, and it was a little bit scary. So one of my friends suggested we look at thread dump. And thread dump is just a list of stack traces for every thread what it's doing. That is not the thread dump from the 2016. I lost all that stuff. It was too long ago, but it's something I did today. And it's it's a worker thread parked somewhere. What's parked? It's waiting for fork join pull something Java thready stuff. And it's a long file with all your threads, right? And you can just take that file, put it in thread dump analyzer, and it says like there is 4 threads parked there somewhere, and then 5 threads parked everywhere. And in that July, it said you have like 800 threads waiting at function called swap. And then, I started reading what is swap, right? Started reading code and documentation finally. And there is a library I took, I felt really smart about picking Clojure. And feeling smart makes you make interesting decisions. And one of the decisions I made is instead of using memcached for caching, as I did all the time in my life, I took Clojure cache, which is just a library implementing various cache strategies on top of a hash map, like a dictionary. And how you manage that dictionary is up to you. And why is it smart? Because it's like local in memory, right? Very fast, no network, super fast. And how do you manage the dictionary? Well, you have some container where you put the dictionary and apply core cache stuff to it, like function and all this shit. And Atom is Clojure's way to manage synchronous state. And how do you manage synchronicity between many threads? You just, do something. And in documentation, they say if any other functions changes your value and your value is not like current anymore, you have to retry the function in a spin loop. And in our case, that spin loop became an infinite loop. Like it was executing this invoke function, which is updating cache. And if there is like 800 guys trying to update something, they're really competing, and this stuff is executing hundreds and thousands of times. And we're just, anyway, it took me like 30 minutes to switch to memcached. I like fuck all that smart stuff. Just memcached, put memcached in place, and we're flying through the sail. Anyway, the key insight here is just learn new tooling, because tooling helps you understand what's going on. And then, it was like a gut check for Black Friday, because Black Friday is the biggest sale for us every year. And on Black Friday 2016, my wife went was put in the hospital for an operation, and I had to somehow feed my little son. And I was really worried about Black Friday going wrong, but it didn't. So it was pretty nice. But then Hello in 2017 happened. And we just moved to a new data center 2 weeks before that. And we started losing TCP packets. The first thing when you start losing TCP packets is it's something with the network, right? So we called our new data center and said you have some problems with the network. So they gave us 10 gigabits unmetered connection to the internet, whatever, guys, just go through a sale. And it didn't help. It actually made everything worse. And we have we have this single page application site, and our JavaScript file, like main.js, is really important to us, because if it's not loaded, the site is not really working. And it can't load because something is happening. And at some point in investigation, we noticed that there is a really high load average on our load balancers. And because of legacy, we were using Citrix instead of Nginx. And I hope you don't know what Citrix is, because it's an abomination. It's like an F5, and I wish I didn't know those words. It's a hardware company making load balancers, hardware load balancers, and they're really weird. Anyway, so while our operation guys were investigating, I tried not to touch them and went on the another floor to talk to the marketing and buying and all the others. And while I was complaining, they were starting remembering what they did. Is that because of new really big campaign with a Nike? I don't know. I don't feel like Nike makes our site slower, right? It's probably should be making it faster. Anyway, so on September, so the thing is, on September 19, load average started growing. We found the chart where the load average started growing. And then it turns out that marketing on September 19th, so it's a month and a half before the sale, published a fourth level of categories. So before that we had women clothing dresses, and now we had wedding dresses, evening dresses, summer dresses, and there is so we had 500 categories, and suddenly we had 2,500 categories. And our API was really dumb, because it was for 500 categories, and it returned all the categories, and suddenly it became a 3 megabyte JSON file. But 3 megabyte doesn't saturate a network connection. And it's just almost like a static file. It's really cached and shouldn't be a problem. But then turns out that two great minds, like me and my main DevOps guy, we're not on Nginx, right? So we can't enable broadly. But what we can do, we can increase level of compression of gzip. Gzip, how do you pronounce that? Anyway, so we put it at 9, which made everything a little bit smaller, and in turn made our load balancer die under the whole 3 megabytes compression stuff. And we put it back into 5, and everything started working normally. And in 2 months, we replaced Citrix's with Nginx's. So it's what everyone should do. All right, and then Black Friday 17 came, right? And oh yeah, fuck, key insight, right? You have to talk to people. Well, not talking to people makes it harder, not easier. And then Black Friday 17 came, And this time my son had a vaccine shot, and he's like, his temperature is around 40, and we're in the hospital, but well, everything is still fine, which is weird. But I started contemplating if I should exit the company before the next Black Friday, because I mean, it's, you know, it's a little bit scary. Anyway, let's. That is a weird thing. Like July 17, it is not a sale. That is a middle of a dead season, right? Nobody is buying anything. We're really low on everything, and suddenly our site dies, and I'm called by my CEO saying like, my wife can't buy anything, and I'm like, whatever. It's 12 p.m. Wait for the next morning. But anyway, after some time, it took 2 hours. We understood that we were being DDoSed. And, well, when you're being woken up in the middle of night, you're pretty dumb. So we're just, our solution was to just wait until, to wait until 3 in the morning. And the guy went to sleep, and we went to sleep as well. So it just finished. But he came back next morning. Next morning. So the problem was, he was making a lot of requests to our server rendering, right? Because of single-page application, most of our load is for API calls, because you're just going through pages without loading the HTML. But first initial load was, we rendered whole HTML on the server, and and it wasn't cached because of user issues and us being lazy, and it wasn't a problem because it usually is like 16 requests per second. Who cares about 16 requests per second, right? But then when it went to 2000, it's PDF did this. It should be better, but PDF. So it's 2000 RPS somewhere there, and it's logarithmic scale. And when it's 2000 RPS, it's really painful. What is interesting in that graphic, I couldn't make Grafana make fonts bigger because it just, the layout went like PDF. And, but it's not a chart from Nginx. It's a chart from our internal monitoring in our application, which reports a type of request. So there are API requests, UI requests, and Django requests. It's from an old version of application. And so it just chose an UI, and we have like 2000 RPS touching UI, which is too much for us. And we couldn't cache, and he went away, and we just, he came back, and we did, well, thanks to that guy, he came back so fast, because if it would be in like 2 months, I would already have forgotten him. But then we just made a extremely clever fingerprinting system and disabled. We just returned the empty HTML with JavaScript initializer, like render it for yourself, man. And I don't know if he did, but that's his problem, right? That's our extra cool fingerprinting system. We just take some headers and combine them with a comma and take SHA-1. Why not MD5? I don't know, whatever. I mean, it worked, and so we have now 2 charts in Grafana. One is called UI, and another is UI client, which is for UI being not rendered on the server. And it's like, up to 150 RPS in that part. I'm sorry for the Russian word, just Grafana doesn't have that information anymore, so I found some old screenshots lying around. So the key insight is that, what the fuck? Right? I mean, we just can't endure ourselves. Why do you came? It's like, was it for something or what? Anyway, the more important one is that building good monitoring is important because it will help you understand what's going on. If we just looked at Zabbix charts, and it just like, it was okay. It's just Zabbix says everything's okay, fine. Anyway, in 2 weeks since that nosy guy came, we have it was called MK Day because we were modna Kasta, and we renamed Kasta, whatever it's called, Kasta Day now. And it's, again, a check, right? So the thing is, at some point when people come, database load increases, application response time increases, and everything is extremely slow. What do? Well, you just take your pgstat statements, which is an extremely useful extension for Postgres, and it makes statistics on all the queries Postgres is executing. And you just reset the statistics, wait for 15 minutes, and see who the fuck is like messing with you, right? And weirdly enough, our product table, which is cached really hard, we just like have multiple layers of cache because, you know, that memcached stuff, and you remember that. It was being hit so hard, like almost one-to-one to RPS of our API, which is weird because there is memcached in front. So let's check cache. And so I check out the code, I run that stuff, and I'm just enabling cache and check, and makes a, like you reload, it makes a request to Postgres, and you reload and makes, anyway, so caching is not working. Why is it not working? Well, because we set everything in the future, you know, and the future is not our future, it's just another thread, right? Just make it calling set to memcached is a network operation, it takes some time. Why would we do it in a synchronous way? Let's do it in another thread. So that thread is eating all the exceptions, right? We just forgot to put items there. I mean, it was because of some refactoring. Somebody changed something, and across like multiple changes, it was we just didn't, which is it just started working better, and then I don't know, we actually, after that, we found a recipe how to catch all the exceptions which happened in futures, because that is something we don't want to be reproduced. Anyway, you know, it's hard, but bit by bit it builds up, and pgstat statements was like our trusty friend for a long time already. And then, yeah, it's weirdly enough, I didn't quit, and nobody got ill, and we just drinked all day long because everything was working. It was the best Black Friday ever. Everything after that was a downhill. Well, because my expectations, you know, were not really high for the Black Friday. I was expecting somebody me in the hospital or something like that. Anyway, so fast forward 2 years, because 19th was really like nothing. Okay, we just worked and everything worked, which is weird. Then came the last year, which is the bad year, right? And then Black Friday is soon. And then somehow, after a new release, our application starts eating CPU. The database is okay, but the CPU is really hurting. So our DevOps guys are starting up new nodes for application. But obviously, with that amount of CPU, we have to have like 100 new servers. And right now, we're running 4. So yeah, which is like, anyway. We deployed previous release and it helped, but the changes were like not understandable. Didn't change much. And but what do you do in that case? Well, you just take out a profiler. Finally, that's a case for profiler, right? We use a Ncl Json Profiler, which is a long name, but it's very descriptive, which is nice. If you look at the end of that, there is a PySpy, which is a fantastic profiler for Python. So I incorporated your suggestion about Python. But anyway, PySpy is really great. Ncl Json Profiler is amazing. So you just connect to a running JVM, and inside of a JVM you say like start profiling, and at some point you say like stop profiling, and it generates an SVG file which you open in a browser, and doesn't really matter what is written in here, right? I will describe. And it says it's CLG time from string. It's from string. This is parsing dates. And where is parsing dates? Well, that is cashback Visa period, and that is cashback Puma. What does it mean? Well, a month ago, we released a very useful product called Cashback. If you pay with a card, we give you 3% back, and after you receive your order, that cashback comes on your account, and you can spend it on our site or just get it back to your card or whatever. We're doing that because amount of people paying with a cash is mind-blowingly high, and it's a little bit painful, and we're trying to get them pay with a card. And marketing is really excited about cashback. It's a new shiny thing. Let's use it for Black Friday. So they go to Visa, and MasterCard, in our country, MasterCard has like 65% of market. Visa is like 35% of market. So Visa really likes us because we do promotions for Visa. And we say, like, Visa, let's do something. And they say, here you have a $50,000. Let's match your cashback. So if you pay with a Visa, you get 6% cashback. Incredible. And then Puma says, like, let's do increased cashback on our products so people come back and buy more Puma. Not like weirdly, right? But anyway, it's only from that point of time, from 16th of November up to Black Friday, and then it stops. So people are feeling like I need to spend their money right now. Right, it's limited in time. You feel what is going on, right? We just put a string of time in our config file, like here's the start, here's the end, and we parse it in a switch. But it was once per request, and then we decided to add a tooltip about how much cashback you're getting for a product. But then product has different sizes, and every size can have different price, so you have execute for every size. And on a single request for a catalog page, you request 60 products for 3 sizes. And it's parsing not the strict date format, but it's using a list of formats and just going through them, finding the one who happens like, I don't know, maybe 20th one comes. So it's like 1,000 calls to parsing date on every request to a server. So what did we do? Well, we just started parsing dates on when config is read. I have just one point here, really. We just did that. And, you know, just don't parse dates. Parsing dates is bad. Also, profiling is fun. It was, like, nice. And then that's the last story. It's about Black Friday. It's a Tuesday of Black Friday week. And we're not doing Black Friday like a Friday, right? Black Friday is a week already, or 2 weeks, or how many, whatever, marketing. So we have that separate product called Hub. It's written in Clojure, and it's the same as our site, the Kasta UA, but it's for suppliers, where you upload your Excel files with your stock or connect with an API. It's like managing all this stuff. And it's weird. 10 o'clock, it just goes down. And you restart it, and it's up for 2 to 5 seconds, and when then going down, stopping making any request to a database. But if you connect to JVM, it responds well. Everything is okay, except you can't make a request to a database. It just is not coming to a database. So we're trying to. So my team lead of that product and the main DevOps guy both DevOps guys went to investigate. It's been 3 hours, and nothing is coming through. So I joined them, another guy just joined us, and we were trying to understand if there is no stack traces. Maybe it's a bug in JVM. We once hit a bug in JVM where it just ate all the stack traces, and we couldn't understand what's going on. But we are trying different versions of JVM, and it's not helping. Then, like, no request coming to DB, maybe it's a network, right? Maybe the network is the problem, but like, seems to be okay, everything's okay. Maybe Postgres driver is bad because we updated it maybe, I don't know, a month ago and whatever. We just tried different versions, everything is the same. And maybe it's a Postgres bouncer, the load balancer for the Postgres. We just, I don't know, everything is working okay, except nothing is working. And we're spending hours and hours and hours. Around 10 p.m., we well, one of us had a marvelous idea. What if we stop everything and just take all the requests which are we sending to Postgres and started executing them directly on Postgres? What will happen, right? And many of them are just being stuck. So we're connecting locally to Postgres with PSQL, and many of those queries are being stuck in Postgres. And it turned out that there is pretty small table, suppliers, which is like 1,000 or 2,000 lines. And one page of that, and it's joined in a lot of queries because suppliers, right? And it's supplier interface. And one page of that table got corrupted on the disk, like disk got corrupted, right? And somehow it's not coming through the RAID or whatever, just, I don't know. We replaced both disks eventually. But then, why did we spend 20 fucking hours? Well, because we thought Postgres is a saint, right? Postgres was so freaking reliable. It always said what is wrong. And this time, maybe it's a bug in Postgres, maybe it's, I don't know. We didn't report anything because we were too tired or already to do something about it. But, well, I don't know. Anyway, we just did too many false directions. We did not keep list of whatever we did because we were trying. Like, we got to use to discover issues with ease. Like when you work for 5 or 6 years on something, you're like a magician, right? You just feel by where it's going, and you like feel like here's the problem, like here's the problem. And this time it's like let's try everything, and it's like 10 hours, 20 hours before we did scientific method with like just let's write down everything bit by bit. So the thing is, I really feel like all that happened because all of us were tired. That was that was tiring year, tiring month, and tiring week. And we were dumb at that point in time. So it took us 20 hours to like go somewhere. Also, everybody's lying, right? Even Postgres sometimes is lying. Anyway, that is all for today from me. Thank you for listening. Did I do it in time?
Yes.